Sir, I submitted.
Submitted? Okay, I can't see it here. Maybe it has not been uploaded. और कहीं है क्या खलील आपके नाम से? नहीं, खलीलुर रहमान यहाँ पे है. अच्छा. Thank you. नहीं, ये तो दूसरा असाइनमेंट है. आतिफ. Okay. थर्ड सवाल आतिफ ने भी नहीं किया. Lattice are the point that represent atoms in crystal lattice, correct? Okay, who else is here? Abdul Rahman. Hishma, when is your iftar? Hishma, am I audible?
Yes, sir.
When is your iftar? Iftar कब है आपका?
6, 8 something.
6, 8 something. What is the time now?
4, 7.
Okay, you have time. You have time. Okay. Thanks. Okay, whose answer sheet is this? Abdul Rahman. Assalamu alaikum. How are you? He got disconnected. Okay, this one is fine, but has a little problem. It should be 2,1-methyl propyl benzene. Okay, so let me discuss this third question here. The question was OBr, then it was C6H4 CH, then in bracket there was CH3 CH2 CH3. So first of all, C6H4 means we have a benzene ring. We have a benzene ring. This benzene ring has ortho substitution like this. So let me write bromine here. Then we have CH, which is connected to a CH3 group and also connected to a CH2 CH3 group. Now, first of all, we have to number this. So we will number it like this. We'll have 1 here and 2 here. And this entity will be, this is obviously bromo. This part is bromo. And then we have this part, which is propyl, and it has a methyl group. It has a methyl group. So the name will be 1-bromo. Then in the second position, we have this whole thing. It is known as 1-methyl propyl. This will be 1-methyl propyl. So in a bracket, I will write 1-methyl propyl benzene. Okay, so this is the name of the compound that was written here. Okay, now who else? Shravya, did you submit the assignments, Shravya? Yes, assignments.
Yes, sir. I was absent on the other 2 days.
Okay, so did you see the recording, Shravya?
Sir, I asked Niskar, sir. But
लेकिन नहीं मिला आपको? You
no,
have
sir.
not got it? Oh, okay. Ask him again, okay? Like,
Yes,
वो आपकी रिस्पॉन्सिबिलिटी बन जाती है कि आपको कंप्लीट करना है जो भी छूटा हुआ पार्ट है. ओके.
Yes, sir, I asked 2 days for the link.
Okay, so other thing what you can do is you can search also na on YouTube. Yes, Shravya.
Okay, sir.
है ना? So what you will do, you will add ME batch class 12 solid state, and then also add Learnivio in YouTube. Okay, so if you enter these words, then you will obviously get the solid state chapter. Okay, fine. और कोई है जिसका हमने असाइनमेंट नहीं चेक किया हो यहाँ पे? I think Khalil's I have not checked because I cannot find Khalil's answer sheet. I will ask sir what happened. Okay. Let us move to today's class. Last class में क्या क्या था हम लोगों ने? Okay, we discussed simple cubic. Okay, we have also discussed body centered cubic. Coordination number is also discussed. And then we discussed, okay, fine. Let us move to the next thing. Okay. So let us revise a bit. We started with 1D packing. Then when I went to 2D packing, I saw that I have two different cases that we can make in 2D packing. What are those two different cases? Tell me. What are the two different cases in 2D packing?
Atoms under atom and atoms under depression.
Atoms under atoms is square close packing, and atoms under AB type. And but the name of packing, remember, SCP, square close packing, and hexagonal close packing. By these names, square close packing, hexagonal close packing, these come from the unit cells that we have. Then when we went from SCP to 3D, we took the base of SCP and made 3D structure. I got two. I got a unit cell, simple cubic, and I got another which is BCC, right? Body centered cubic. So these are the two different type of unit cell that I got, arrangement that I got in terms of 3D. Now, you guys will tell me, if I compare SCP and HCP, which is better solid? Which is better solid?
HC.
Yes, very good. HCP is better solid. If I compare simple cubic and BCC, then which is better? Between
BCC.
simple cube, BCC is better. Very good. So one thing I can see here is that if I put atoms under atom, that I have done in SCP, and if I put atoms under atom as I have done in simple cubic, in both these cases I have put atoms on atom, and as a consequence, what I am getting a bad solid. I'm getting a worse packing. So a better way to make solid is to put atoms on the void. Is that right? Yes or no?
Yes, sir.
You understand the funda? So what I will do in HCP, I will not do the case of atoms under atoms. I will be directly doing the case of, I will be putting atoms on the void only. Okay, I will be putting atoms on the void. I will be taking the HCP arrangement as the base layer, and then I will be putting atoms on the void. Then we'll see what type of solid we are getting. What type of solids are we getting? Okay. So first of all, what I have to do, I have to make a HCP lattice. And please remember that all of these things are what? These are spheres and these are not circles. Okay. Assalamu alaikum, Saif. How are you? Yes, Saif. Am I audible? Hello. No, Saif for disconnect again. No, he's here. Yes, Mohammed Saif.
Yes, sir.
Yes. Okay, I'm audible. Okay, fine. How are you? Fine.
Alhamdulillah, sir. How are you?
I'm also good. Okay, by the way, Ramzan Mubarak to all of you. Okay. Ramzan Mubarak to all of you. I forgot that this is the first time we are interacting after Ramzan. I mean, in Ramzan. Okay. So all of you can see that this is the HCP type of structure, that is hexagonal close packing. But please remember, all of these are spheres. These are not circles anymore. Now, the first thing that I will observe here, is here in this case is the voids. Thank you, Sayyid Muhammad. The voids that I can see here is two type of void. We have an upward arrow void, an upward triangle void and a downward triangle void. Is that right? All of you can see that? Yes or no?
Yes, sir. Yes.
Okay, fine. Now what I will do, I will say that in HCP, I have two types of voids. All of them are triangular void, I can say, but there are two types of triangular void. We have an upward arrow, upward triangle void, and then we have a downward triangular void that I should make with some different color. Now, listen very carefully. When I take an atom and I place it on top of the upward triangular void, I place it on the upward triangular void. Okay. So this atom, I am placing it on the upward triangular void. As soon as I put an atom on the triangular void, I have converted it into a tetrahedral void. Is that right? Yes or no?
Yes, sir.
Right.
Yes.
This is a triangular void. But as soon as I have put an atom on the triangular void, I have converted it into a tetrahedral void. So let me add atoms, more and more atoms. Now, look at this void that was downward facing. Right? So we had the upward facing void, which is now converted into tetrahedral void. We had this downward facing void, downward triangle. Okay, this downward triangle, you can see that it is converted into which void? You guys will tell me. It is converted into which void?
Tetrahedral void.
No, not tetrahedral void. Look again. Look at these atoms, the black atoms. First of all, look at the black atoms. Right? They're making an upward triangle. Then look at the blue atoms. If I join the midpoints of the blue atom,
Octahedral.
octahedral void. All of you can see that. What about others? Yes.
sir.
Anna? So octahedral void. That is why I said that you will get this type of arrangement of atoms in one layer, which is making a upward triangle, and the other layer will be making a downward triangle. And this arrangement will give a rise to octahedral voids. Okay. So what I can say that these triangular voids are converted into, the upward one is converted into tetrahedral voids, and this downward one is converted into, let me write it, TV. Tetrahedral void as TV. This is now OV, octahedral void. Okay, this is octahedral void. Okay, let me make a few more atoms, then you will see something else happening. Now, I want your focus on these atoms of the blue atom, these blue atoms. Okay. This blue atom, this blue atom, and this blue atom. Can all of you see this void here? Yes or no? What kind of void is this? What void is this? It may look like triangular void, but can you see just below that triangular void, an atom is present, a black atom is present, right? So it is a tetrahedral void, right? Yes or no?
Yes.
This will become this is a tetrahedral void because we have this black atom also. This is a tetrahedral void. That means we have two kinds of tetrahedral voids. I have two kinds of tetrahedral void that I need to also name it properly. And I have two kinds of tetrahedral voids now. Now, how will I name it? See, the first tetrahedral void, it has 4 atoms, right? This first tetrahedral void, it has 4 atoms. We have 3 black atoms and 1 blue atom, correct? Yes or no?
Yes, sir.
and this black atom is the first layer. So I will say that since this tetrahedral void is made by the atoms of majority atoms are of first layer. Okay, this tetrahedral void is made by atoms and the majority atoms are of the first layer. That is why this is the tetrahedral void made by layer A. And these second type of tetrahedral voids, they have a majority of blue atom, which is the B layer, and hence I will say that these are the tetrahedral voids made by B layer. Is that right? Yes or no? Please tell me. Everything
Yes.
is clear till here? Okay, Huzaifa, can you please turn the mic on?
Yes, sir.
What are you asking? Tell me.
So you said the upward facing and the downward facing, they'll have different types of voids in 3D, right?
They are, yeah,
This will have triangle.
these are
and that
triangular
will have-
voids only, but these are different, right? I mean, different in the sense that that is also triangular void. Okay.
So what's OV over here? It's
See, it has been converted to octahedral void after putting atom. See, triangular void was there. When I put atoms, then it has become, this red one has become tetrahedral voids and the yellow one has become octahedral voids. That was I was trying to say. Got it?
okay. Yes, sir.
Got it now? Okay. So after
Yes.
putting atoms, okay, after putting atoms, we have converted the triangular voids, the upward facing to tetrahedral, sorry, upward facing, yeah, to tetrahedral and the downward facing to octahedral. Okay. Till here, everything is fine.
Yes, sir.
Now,
Okay, sir. Thank you.
okay. Now what we are going to do? Now we are going to put atoms again in the void. We will never put atoms on the atoms. We will put atoms on voids only. So we have three voids here, right? Tetrahedral void by layer B, tetrahedral void by layer A, and then octahedral void, and then octahedral void. So let me start by putting atom on the tetrahedral void of layer A. Tetrahedral void of layer A. So I am marking a few voids here, and you will tell me which one of them is the tetrahedral void of layer A. One, 2, and 3. So you guys tell me. Oh, the black one is the layer A. Black one is the layer A, and the blue one is the layer B. Okay, Shravya. So I have marked three voids, right? We have three voids: tetrahedral void of layer B, layer A, and octahedral voids. Now I want to put atoms on tetrahedral voids of layer A. So you guys tell me which one of these voids is tetrahedral voids of layer A? 1, 2, or 3?
1.
All of you can see that it is 1, right? It is 1. So now what I will do, I will try to put atom on 1. So I am trying to put atom on the first layer. Let me make it green. Okay. But in reality, what is happening? I am putting atoms on atom, right? Yes or no? I have put the green atom on blue atom, correct? Yes or no? Because this is the second layer. Blue layer is the second layer, right? The black one is the first layer. Then we have the blue atom. And when I want to put atom on this particular void, I am putting atoms on atoms. All of you can see that, yes or no?
Yes.
That is why what I will say that this is not a useful part, not useful. Because if I want to put atoms only on voids, not on atom. But if I try to put atoms on tetrahedral voids of A, then actually tetrahedral void of layer A is already covered by blue atoms. So there is no point of putting one more atom on top of the other atom. That is why this is not useful. So we have only two types of voids left, which has to be covered, You can see that this green void is not covered, right? This green void is not covered because the black atom is inside, right? The black atom is a lower layer. Okay, it is a lower layer, and hence I have to put atoms on this green void first of all. So let me put atom on this green one. So if I put atom on the green one, please remember that the blue atoms are the top atoms, okay, and the black atom is underneath, but as soon as I put atoms here, you can see that it is again the black layer coming. Yes or no? So we had the black layer,
Yes, sir.
and then we had the blue layer. And when I want to cover the tetrahedral void, again I will be making a black layer. Correct? Yes or no?
Yes.
Yes, sir.
Right? That means if I put atoms on this void, I will get a packing which will be A, that is the black layer. Then I will cover with the blue layer, B. And then when I want to cover the tetrahedral void made by the blue layer, I will again get the A layer. Then I will cover the voids of A layer, I will get the B layer. Then I will again cover the layer of, I will again cover the voids of B layer, I will again get a A layer. So this is AB type of packing that I will get in terms of tetrahedral void of layer B, tetrahedral void of layer B, if I want to cover the tetrahedral void of layer B. Now let me just get this a bit smaller. Okay. Now let us focus on the octahedral void. Okay, let's focus on the octahedral void. So first of all, let me get a new clear octahedral void here. Now, this is the first layer. Black layer is the first layer A. Then we have the blue layer B. And then I want to cover this yellow octahedral void. Okay, I want to cover this yellow octahedral void. Let me take a atom. Let me take green atoms. Okay. Now, as you can see, this is completely new layer, right? Yes or no? This green layer.
Yes, sir.
Right, this is completely new. Okay, let me make a few more atoms. We have a green layer, green atom here that is covering the white. This will be a bit here. Then again a green atom here covering the next octahedral void. And then there will be a green atom here covering this octahedral void. Okay, so the octahedral voids that we are trying to cover are this void, and this void. Okay, so we have covered all of these voids, the octahedral voids. Now this is going to be very, very, very useful. If I put atoms on the octahedral void, so we had layer A and layer B, right? So the black layer and the blue layer, they were making octahedral voids, yes or no? Correct?
Yes.
And to cover that octahedral void, I put layer C, that is the green layer. Yes or no? Right.
Yes, sir.
Now look at the blue atoms that I am circling. Look at this blue atom. Look at this blue atom. Look at this blue atom. It is making an upward triangle. Now focus on these green ones. It is making a downward triangle, yes or no? The blue atom is making a upward triangle. The green atoms are making a downward triangle. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Right. Now, then we have a new void that you can see. Let me take a different color. What color should I take for this one? Starry. So this is the new void, and this is an octahedral void, right? Correct? Yes or no? All of you
Yes.
can see this void, this new octahedral. Now let us cover this void. So this octahedral void is made by layer B and C, layer B and C. And when I went to cover this void, as you can see, I am putting atom and making again the black layer, right? Just above the black layer, correct?
Yes.
Okay, that means layer A and layer B made octahedral void. To cover that, we had C layer. Then B layer and C layer, they made octahedral void, and to cover that, we had again A layer. Okay, so you will have A, B making octahedral void. To cover that, you will put atoms on C layer. Then B and C will make octahedral void. Okay, B and C will make octahedral void, as we have seen now. To cover that, you will put A layer. Then C and A will make octahedral void, and to cover that, you will put B layer. Then again, A, B will have octahedral void, and to cover that, you will put C layer. So as you can see, I have made ABC type of packing. If I put atoms to cover the octahedral void, is this clear? Yes or no? Please tell me.
Yes, sir. Clear.
Okay. Now take your time. Take your time. Draw whatever you can, but please understand each and every part, whatever you're drawing. And this drawing is less important. This table is more important, and you understand this table also. Okay. Each arrow, please remember, each arrow tells me about putting atom. So I am putting atom here and here. So these are all same level. Okay. So when I put atoms here now, please remember that I have put only one layer till here. Okay, I have put only one layer till here. And after that, we have tetrahedral voids and octahedral voids, and we are focusing at them individually. Till here, I have only put one layer. Please remember that. Okay, till here, I have put only one layer of atom, that is the blue layer of atoms. And I have got tetrahedral voids made by blue layer, made by black layer, and the octahedral voids. Please copy this down. Raise your hand when you are done. Then we will move and start learning about the ABC type, and then unit cell, Z, packing efficiency, etc. Can you start copying? Hello, Aisha.
Good evening, sir.
Good evening. You joined in the previous class now? Yes, Aisha?
Sir, for half an hour, and then I had another class.
Then you had another class. Okay. So you joined now. Okay, fine. When is your iftar, by the way?
There's still 1 hour left.
1 hour. Okay. So are you done till here?
Yes, sir.
Okay, fine. Okay, Pravya is done. Waiting for others. Waiting for Atif, Abdul Rahman, Huzaifa, Khalil, and Muhammad Saifullah and Sayyid Muhammad.
Sorry, message in private that I finished.
Acha, raise your, okay, fine. Sayyid Muhammad is also done. Atif is also done. Okay, Huzaifa is done. Okay, Abdul Rahman is also done. Saif, what about you, Muhammad Saif?
1 minute, sir.
Okay, okay. Yes, Saifullah, done. Hmm.
1 minute, sir.
1 minute. Okay.
Yes, sir, done.
Okay, very good. Chalo. Now, let us try to, you guys can lower your hand. Let us try to, first of all, find a unit cell for ABC type of pattern. So for that, what I will do, I will make a few atoms here. And blue atoms, है ना? Now what I need a third layer, that is green one. Okay. So I've got all of these layers, but I need to erase a few things because इतना तो नहीं चाहिए ना, इतना तो नहीं चाहिए. Let me see if I can make out a few atoms that I need. Okay. Okay, I think this much will be fine. Let me take an atom from here. Okay, let me take this black atom. And let me make it here. Okay. And after that, I will take some blue atoms. So the blue atoms that I will be taking are these blue atoms. A blue atom from here, 2 from the next layer, and then 3 from the next layer. So these are the blue atoms that I'm going to take. So if you remember, unit cell you can take any type of or any arrangement of atoms, but I am taking those which are most useful. Okay, the one which are most useful. I will take the green atoms also in similar fashion, but they will be just in an opposite direction. So they will be facing it like this. You make it green and just rotate it vertically. So these are the green atoms that I will be taking in order to create a unit cell. Okay, and then the last will be again the A layer. So unit cell has a very specific property that when if you start with a layer, you have to end with that layer only. Okay, so the cycle is complete. You're taking all the atoms into consideration. Okay, all the layers. You start with A layer, then B layer, then C layer, and then again we have the A layer. Okay, so this is the unit cell that I'm taking. It may look very weird, and you may see that इससे क्या ही बन जाएगा. But let me first of all plot all the midpoints and try to join them. Okay, I will take the midpoints of these atoms and I will join them. So for the black one, I will take black point like this. Then for the green one, there is a green atom just below this black atom. So I will make green atom here, just below the black atom. Then there are 2 green atoms here and here. Then there are 3 green atoms, which are, there is one here, there is one in just the middle. Okay, let me just make it a bit lower. Yeah, and then there is one here. Okay. Now we have a similar arrangement of the blue atoms, but in vertically opposite directions. So I will just copy and paste this, make it blue, rotate it vertically, and I have got the blue atoms arrangement also. So let me just add just one of these. I think this should be a bit here. Similarly, this should be a bit lower somewhere. Yeah. Now these are the blue atoms. Then we have one black atom here. Okay. Now let me try to join them. अभी इसको थोड़ा नीचे करना पड़ेगा, I think. Yeah. Okay. So let me try joining them. Can all of you see a cube in making, yes or no?
Yes, sir.
Can you see all the atoms are in corners and in the face center? Yes or no? All of you can see that, right?
Yes, sir.
Right. Okay. So see, it may be looking weird at first, but at the end, you can see that we have made a particular unit cell, and it is a cubical unit cell, and more specifically, it is a face-centered cubical unit cell. Okay. So please start making while I am making the orientation, which is more familiar to you guys, which is like this. Make it black in color. C and V, put it here. Then join these lines. Okay, so please, you guys also start. Okay, so here we have a black atom. Just vertically opposite, I will have a black atom. And this black atom is touched by 3 blue atoms. So we have a blue atom here, we have a blue atom here, and we have a blue atom here. And this black atom is touched by green atoms. So we have a green atom here, we have a green atom here, and we have a green atom here. Now let us talk about the face center. Let's talk about the face centers. So the blue atoms, if I see, it is present here in this, where we have 2 blue atoms. Here we have a blue atom, and here we will have a blue atom in these face centers. Then if I talk about the green atoms, we'll also have a blue atom somewhere here, I think, in the, let me picture it correctly. Yeah, this down layer will also have, this bottom face will also have a blue atom here, right? Then the green atoms. So the green atom will be here, and the green atom will be in this wall here, I think, somewhere. Yeah. And the green atom will also be on the top here. So this is the top, and these are the 2 faces. Then these are the 2 faces. I think this will help you picture it more correctly. Raise your hand when you're done, okay? The unit cell is face-centered cubic, also known as FCC. And the packing is known as cubic close packing. Okay, so ABC type of packing or cubic close packing. Also remember one more point. These two words, they will be used generally interchangeably. Okay. So please remember FCC is the unit cell of CCP. The cubic close packing is a whole arrangement of atoms, different atoms, and out of this we have taken a unit cell, which is a face-centered cubic. Okay, so FCC is the unit cell of CCP. Remember this line. Please draw it fast. Okay, and rather than trying to copy it, you try to logically derive it yourself. Okay, you have the black atom, the green atoms. You can copy this much part, but after that you have to. So you have to convert from here to here on your own. That I would like. Don't try to copy this part. Okay. Ishma is done. Waiting for Atif, Abdurrahman, Huzaifa, Muhammad Saifullah, Sayyid Muhammad. Also, I want your focus one more time in this portion. So all these three atoms are touching. All these three atoms are touching, and all these three atoms are touching. So if I want to see these atoms, then these are these atoms, right? These atoms and these atoms. So essentially what you can see is that all the corner and the face centers, okay, so from corner to corner via the face center, these atoms are touching each other. Okay, so this will be helpful in the derivation of relationship between A and R, the relationship between A and R. Okay, please remember these are the atoms which are touching each other. These are the atoms which are touching each other. These are the atoms which are touching each other. Okay, these are the atoms which are touching each other. So from corner to corner via face center. So write this down. Okay, so who is left? Aisha and Sayyid Muhammad. Aisha, are you done? Aisha, are you there? Hello. Okay, Sayyid Muhammad ka ho gaya. Okay, Aisha has sent me a chat, I think. Done. Okay, fine. Acha, one more thing I wanted to point out in this whole ABAB type and ABC type, that you can see that there are two tetrahedral voids and one octahedral void. Okay, so also write one more point here if you have some space. Both packing, right? Rather in both packing. PV is double than other twice. TV is twice of OV. Okay, that is octahedral void is equal to N. Then tetrahedral void is equal to 2N. Okay, octahedral void is N. If there are N octahedral voids, there will be 2N tetrahedral voids. I will tell you guys what is this N in a while. Then all of you, yes or no, please tell me.
Yes, sir.
Okay, fine. Now, let us move on. And let us first of all try to think about the coordination number of FCC, coordination number of FCC. Now for this, again, I want your focus here in this part, okay? In this part. And I want all of you, okay, rather not here, let me get your focus somewhere here. Yeah, I think this is better. Yeah, this is going to be better. Okay. Just need one more atom. Make it blue. Put it here. Okay. Then maybe I need one more atom, that is a green atom. Okay. So I want your focus on this blue atom. All of you can see this blue atom, yes or no? This blue atom, okay? Fine. All of you can see it, yes or no?
Yes.
Yes, sir.
Okay, so this blue atom on its own layer, okay, so it is touching 6 blue atom, right? 1, 2, 3, 4, 5, 6, right? This blue atom here, it is touching 6 blue atoms, correct?
Yes, sir.
Okay, fine. So 6 blue. Now plus. It is also touching these green layers, yes or no? 3 green atoms on the top layer,
Yes, sir.
right? And at last you have to see, so we have got 3 from the green layer, and at last the bottom layer, this blue layer was on the top of these black atoms to make a tetrahedral void, hai na? Yes or no? So plus 3. So in total we have
12.
coordination number is 12. All of you can see that, yes or no? Please tell me.
Yes, sir.
Okay, so the coordination number is equal to 12. Okay, so I have shown you guys using the packing. This is the packing. Let me show you using the unit cell. Okay, using the unit cell. Okay, now I need to let me. अब देखिए इस वाले green atom को. Okay, all of you look at this green atom here. Can all of you see this? Yes or no? This green atom.
Yes, sir.
Okay, so it is touched by these 4 atoms, correct? The 4 atoms on the corners, these 4 atoms. Yes or no?
Yes, sir.
Right, this is touched by these 4 atoms. Okay, now all of you, what you should do, you should imagine this atom, this green atom, which is placed instead of your fan, है ना? This is the ceiling of your room, and instead of fan you have an atom there, a big atom. Okay, a big atom. Then on each wall in the face centers, that means the center of all your walls, there will be one atom poking out. All of you please imagine that, and if you imagine it correctly, otherwise I will prove it mathematically. Okay, you will see that this green atom will also touch these 4 atoms that is present on the walls. Okay, so how many is done? 8 is done till now. 4
Yes,
in the
sir.
same layer, 4 in the below layer. Now this face center, this ceiling is also present in the room above, right, in the next floor. So the next floor will also have similar type of 4 atoms on the walls, and this green atom will be touching those 4 atoms also. So 4 in the above layer, 4 in the same layer, and 4 in the next layer. That means we have again 12. Yes or no? Yes or no, guys? Okay.
Yes,
Now,
sir.
in order to prove it mathematically, how will you prove it? So we have to prove only one thing. We know one thing, that these atoms are touching each other, right? Yes or no?
Yes, sir.
We know that this is touching each other, and the distance between these 2 atoms will be a root 2 by 2. Any doubt about this distance? No, na? You remember face center, है ना? All of you remember face diagonal has a root 2 and it is in the center. That is why it will be a root 2 by 2. It will be a root 2 by 2. Okay. Now we have to only prove that the distance between the distance between these two atoms, that means the ceiling center and the wall center, है ना? The ceiling center and the wall center is also a root 2 by 2. We only have to prove that. How will I prove that? So whenever you have to calculate the distance between two points, we will use the Pythagoras theorem. We will use the Pythagoras theorem. Okay. So we have to calculate this distance. Okay. So we have this distance. We have made a right angle triangle. I hope you guys know that this will be a by 2 and this will be a by 2. Yes or no? Right, guys?
Yes, sir.
Let me erase this part. Okay, just wait a second. Okay. Okay. So this yellow one will also be a by 2. Just stop me if you don't understand why it is a by 2. Okay. And this will be also a by 2. All of you clear why this will be a by 2 and a by 2? Yes or no?
Yes.
Is there anyone who has any doubt why this will be a by 2? No. Okay. Now what you need to do, this is our hypotenuse. So hypotenuse will be equal to a by 2 whole square plus a by 2 whole square under root. है ना? So this will be equal to how much? Calculate it. You will have 2a square by 2. Right? Yes or no? Let me write it here. H square will be equal to a by 2 whole square plus a by 2 whole square. This will be equal to a square plus a square divided by 4, which will be equal to 2a square by 4. है ना? And h square is equal to 2a square by 4, and hence h will be equal to a by root 2. A by root 2. Is that right? A by root 2. Correct? Yes or no?
Yes.
Okay. And what was this distance? This black distance was a root 2 by 2. So essentially this is also how much? A root 2 by 2. Root 2. So this will be also a by root 2. Correct?
Yes, sir.
Hai na?
Yes, sir.
So now we have proved, now we have proved that the distance between the face center and the corner and the face center between the face center of ceiling and the face center of the wall is same, and that is why they will touch each other. That is why they will touch each other, and hence the coordination number is 12. The coordination number is 12 only. Okay, fine. So let me erase these parts because these are not useful for you. The only useful thing is the coordination number. The coordination number. Now let us find out the z. Now I want all of your input in z very enthusiastically. Okay, so z. So for z we have two types of atoms. What are the two types of atoms in terms of the position? We have corner atoms and what type of atoms? The atoms that are present in some atoms are present in corner, yeah, and some atoms are present in face center. So we have corner. How many are present in corner? How many are present in corner? How many are present in corner?
8.
8 are present in corner. Very good. What is the contribution of each of them? Yes, Aisha, correct. What is the contribution of corner 1? What is the contribution of corner
I
1?
think 1 by 8.
Yes, not think. It is 1 by 8, which will be equal to 1. plus we have another, which is the phase center. How many are there in the phase center? How many atoms in the phase center, guys? How many atoms in the phase center?
6.
6. Very good, Aisha. We have 6. What is the contribution of each? What is the contribution of each? What is the contribution of
Sir,
each?
1 by 2.
1 by 2. This will give me 3. So Z is equal to 3 plus 1, which is equal to 4. Any doubt till here, guys? Any doubt till here, guys?
No, sir.
No. Next is the relationship between A and R. Relation between, don't write anything, just listen. Relation between A and R. For relation, we have one thing that you have to remember, atoms touch, yes or no? You remember this word? We can find the relationship between A and R with those atoms which are touching each other, Now let me make a face. This is my face. We have atoms. It's kind of a cheating, but still what I can do. Okay. Right? And we know that what is the length of this phase diagonal? It is A root 2. This is R. So this is the center. This will be R, and this will be also R. So you can see that the relationship between A and R will be A root 2 is equal to 4R. Is this clear, yes or no? Relationship between A and R?
Yes.
है ना? We are taking these atoms. Please remember, we are taking these atoms, okay? These atoms which are touching each other. These atoms which are touching each other. Okay. Next is packing efficiency. So packing efficiency. What is the formula for packing efficiency, guys? Look at the BCC and tell me. Look at the BCC and tell me. There is not one formula, okay? So for each of these unit cells, the formula will be different. But some things will be same.
Sir, it will be 4 into 4 by 3 pi r cube by a cube.
Yeah, very good. 4 into 4 by 3 pi r cube upon a cube. So I can write this as 4 into pi into r cube divided by, for a cube, what I will write? I will write it as a is equal to, I can see, according to the relationship, it is equal to 4r by root 2. So I can write this as 4 cube into r cube, and root 2 cube, I can put it here. Root 2 cube, not square, rather cube. And this 3 will come here into 100 into 100. Then I can see that I can eliminate this 4 by this cube, this r cube and this r cube, and I will be left with pi into root 2 cube will be 2 root 2 divided by 4 into 3 into 100. So this will be what? This will be 2's. Then I can eliminate root 2 into 2 by root 2, and I will be getting pi by p root 2 into 100. Okay. So all of you guys start writing, I think from here. You can see from coordination number, yes or no? I think you have written till here. Start writing from coordination number of FCC. Tell the packing efficiency. Calculate the packing efficiency and tell me. Okay. All of you can see it ना? या zoom कर ले थोड़ा हम. All of you can see it seems. Okay, fine. Zoom करना हो तो बता दीजिएगा. Yes, yes. Send the answer of packing efficiency. Send the answer for packing efficiency in the chat. Yes, Atif, correct. Very good. Yes, Shravya, correct. Very good. Yes, Josefa, very good. Correct. हाँ, हिश्मा नहीं 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 नहीं, कुछ गलती हो गई हिश्मा आपसे. Try again, try again. Hishma, what is the value of root 2 that you took? What value of root 2 did you take?
1.41.
Yeah, that is correct. कुछ थोड़ा सा मिस्टेक हो गया कहीं पे आपसे. Yes, मीनाक्षी करेक्ट, खलील करेक्ट. आराम से कीजिए हिश्मा, ओके, हड़बड़ाइए मत. हाँ, yes, सैयद मोहम्मद approximately correct. Yes, Saifullah correct. Okay. हिश्मा, आपका अगर आंसर आ जाए तो आप बोल दीजिएगा माइक ऑन करके, चैट में मत लिखिएगा। हिश्मा आया आंसर? नहीं, चलिए। Okay, Hishma, you calculate it. Okay, Hishma, you calculate it. Others, you can write the last point about the voids. So the number of octahedral voids is equal to n, where n is number of atoms. Okay, please remember number of atoms. Now, since we are talking about the unit cell FCC, we're talking about the unit cell FCC. In FCC, the number of atom is equal to 4, and hence the number of octahedral void will be also equal to 4. And tetrahedral voids is equal to 2n, and hence it will be equal to 2 into 4, that is equal to, there will be 8 tetrahedral voids. Okay. हिश्मा, आंसर आया आपका?
No, sir.
नहीं आया, वही 68 ही आ रहा है अभी भी।
Yes, sir.
अरे ऐसे कैसे 68 आ रहा है? ये पाई को आप 3 लेके चल रही हैं क्या? हिश्मा, I hope you are taking this as 22 by 7 or 3.14. If you calculate it correctly, the answer will be 74%. Okay. You void. Okay. Guys, हो गया? Octahedral voids and tetrahedral voids, yes or no? Khalil, Huzaifa, Minashi, Saifullah,
Done, sir.
Shravya, done na?
Yes, sir.
Okay. So what did we learn today? We learned a few things, right? We learned few things. The important things that we learned today was, first of all, let me revise. We had 1D, and after 1D we had 2D, in which we had two types, SCP and HCP in 2D. Okay, so after that we saw SCP. In that also, when we went to 3D, this is now 2D. When we went to 3D structure, we had two: simple cubic, unit cell, and we had body centered cubic unit cell. Now HCP was a bit different. So when we went to HCP, what we saw that HCP has two different types of voids. We have a upward facing void and a downward facing triangular void. So when I put atoms on upward facing triangle void, these were converted to tetrahedral voids of layer A, and these were converted to what? What were these voids converted to?
Octahedral voids.
Octahedral voids. And as I laid out the second layer, I got a new type of void, which was a tetrahedral void made by the second layer. Then we started to put atoms next. If I put atoms here, it was not useful, right?
Atoms
When I
on
put
atoms.
atom, yeah, it was becoming atoms on atoms. But when I put atoms on the layer tetrahedral void made by layer B, I got a packing which was AB type packing that will be studied tomorrow. And if I put atoms on octahedral void, which was made by A layer and B layer, and then I covered the octahedral void made by A layer and B layer by C layer, then B and C layer made an octahedral void, which was covered by A layer, and then again C and A made an octahedral void, which was covered by B layer, and then again C layer, and so on. So we got ABC type of packing, and this ABC type of packing is the cubic closed packing whose unit cell is FCC, and this unit cell has a coordination number of 12. It also has the packing efficiency of 74%, and the Z of FCC is equal to 4. The Z of FCC is equal to 4. So these are the information that you have to memorize. And furthermore, please remember, you have to memorize a few information, that is face diagonal is A root 2, body diagonal is A root 3. Okay. Then what else? You also have to memorize the contribution of face center atom is half. The contribution of edge center atom, the atom, if it is present in edge, it is equal to 1/4. If an atom is present in the corner, it is equal to 1/8. And if it is present in the body center, it is equal to 1. And so these are the things that you have to memorize, at least these. Okay. Please memorize at least these information, and others you can derive more conveniently. Okay. But if you can remember these also, then it will be very good. Okay. At the end, you have to remember these also. Okay. Coordination number, Z, packing efficiency. Coordination number, Z, and packing efficiency. These are the most important. And there is another one, which is relation between A and R, which is not very much important, but it has some importance, you can see. Then you also have to know everything about the voids. Okay. So these are the few information that you have to know about a particular